Yeah, it's one thing to talk about what, when, how, down the line, but before that, some people could argue saying, okay, Nanda, but you don't need to do that. You could outsource all that. But how are you an artist if you outsource your work? I mean, I always have to manage in my head how much I want to outsource and how much I want to keep to myself, doing myself. Check it out. I was just outlining the new PCB, where to put the connectors on it and such. How to fasten it. There's an encoder there. Same old man. It's still the robot. That's the end effector in that. Senses its position. Same old. This sound will fit the rest of the robot. And I'm like, man, it's so much work doing this. I don't know if you can imagine how long it takes or how much work, because I used to calculate stuff in time, like how much longer do I have to wait, or do I have to do something till something happens? But I realize it's got not too much to do with time, it's how efficiently you do something. The amount of moves that are necessary, the amount of moves in the CAD program that are necessary to produce a robot, I love it. I love it. I love it. It's a robot. I have to train myself mentally for the readiness of this. A DHL courier guy carries it in their hand, or whatever other package carrying service, I don't care. They carry it. They're like, here you go. And they're like, whoa, what's this? And the courier's like, I don't know. No, just joking. They will know what it is. It'll be the robot. And they'll just take it in their hands with the power supply. And everything, man. Everything. Power supply. Powder coating equipment. And the robot itself will be in a singular box weighing less than 12 kilos. Ha! Okay, now let me show you something out back. Let me show you something. Do I want to do this now? I mean, it's an old robot. Do I want to compare? I wanted to go out and show you, but it's a 1993 ABB Tralfa. I wanted to show you the top 3-axis motors weighs more than 12 kilos. I can show you one of the bottom axis motors weighs about 10 kilos. The robot itself was about half a ton. Plus the power supply is like 300 kilos. Power supply and control equipment. But that's 2.7 meter reach. I mean, this could be a 2.7 meter reach. Would it be more than 12 kilos? Possibly not. Possibly not. Kevlar honeycomb in the carbon fiber arms, and it's so lightweight, man. It's gonna be so lightweight, lightweight. But designing it is challenging. I have to say, it is challenging, tedious. It is tedious and also challenging. There's loads of ways to do something, kids. This is what either you understand or you'll find out. It's not something someone tells you and you understand the concept, but I will try anyways. When you're designing something, you can. It's up to you. It's completely up to you. There's no rules. There's safety criteria that you have to comply with, but there's no rules on what materials you use. I mean, it has to be fire retardant to a certain level. It has to not shatter in case of an explosion, so on and so forth. ATEX, explosion proof criteria, applies to within the booth. So man, but within the guidelines of those requirements, you can pick any amount of materials, parts. Like, I was just planning the fastening of this. I wanted to I wanted to snap in place. I want this PCB to snap in place. But you see the screw holes. I put 5 screw holes, and also on the rear side. This pink stuff is just a 3D printed piece of plastic. I put receptacles for the screws So you could be like, okay, yeah. Initially I wanted two. I was like, let's put one in the lead area on the top, put one there, and I put two on the bottom then. But when I was just thinking about two, I'm like, okay, I could put a brass insert in there, threaded insert nut, and I could screw an M2 screw in there, and that would be neat, hold it in place. It adds weight, and you'd be like, okay, yeah, that's two brass inserts that you have to use for the robot. But you remember our little mind game yesterday or the day before? I can't remember. It was about 30,000 robots, so that's 60,000 brass inserts. And now I'm sitting here in this Cloudliner and thinking to myself, not necessarily this time, but like all the time when I'm designing something, is that's the level of detail at scale that you have to take into account. That's why it's difficult. Not because it's difficult to design a robot that works. No, that's not the difficult part. But the difficult part is to design it with the minimal required parts. And it's still far from it, man. It will be below a kilo, a powder coating robot, uh, before I die. Yeah, man. Before 2030. So I can't stretch it enough. Just get down to it, design it, and you'll see. Okay, so if I want to build 100, like I will keep the pieces in this little box. It will take up this much floor space. Like it adds to your factory or assembly floor space. 60,000 brass inserts fits in a few cardboard boxes still, but every single part you have to take that into account. Let's say you run another meter, another wire. You choose a bus for the internal communication of your robot. We chose CAN, in this case, CAN bus. And if you've got a 2 meter robot, you add another strand of wire, you got 30,000 robots. That's 60,000 meters, man. It's 60 kilometers of wire you just added by, okay, my bus system requires one more line here, one more communication line. Boom, 60 kilometers of wire has been added. And it's, I try not to find it stressful. I'm just looking for the right word here as to, it could be stressful. This could be very stressful. I find it extremely challenging. I try to look at it objectively, as in my subjective opinion is that fuck all of these parts, man. Just give me the minimum. I don't want any wires. It's gonna be all Wi-Fi equipped, all the actuators in the robot, and we're gonna try that. We're gonna try maybe a simultaneous communication of Bluetooth and Wi-Fi, sending out inverse kinematics data in advance through robot joints, so that there isn't a need for live communication constantly, to try to eliminate wires, man. Hundreds of kilometers of wires could be eliminated. So I try not to find it stressful, because even if I didn't give a shit about any of what I'm talking about right now, I'll put all the brass inserts in there, all the wires, that whatever, man. It's still just the weight is just 10% of current robots that can do this task. So game is already won. I mean, no, because it hasn't conquered the world, but already on track to winning. It's just a personal challenge with yourself, which is hard because you can never really win. Even if I half the kilos, I would be like still like, man, that's still 4 times as much as I want. so so you have to draw a line and try not to blow it, because, well, I don't know because why. It just takes too much time to try to figure it all out, to try to figure it, to never stop, to be relentless on this quest for less. It's tiring. Yeah, that's the best way to put it, that it is draining on your energy to always be reevaluating every single part of your machine. It's not easy. And yeah, but it is challenging. It has your mind going around and round and round. Not as in running in circles, but round and round, checking all options again and again, in combination with different parts of the machine. Anyhow, let's continue.